Number 5 is a little bit unique because we have two radicals in it, and one of them is already isolated on the left-hand side. So we're going to square the left and square the right, and we're going to have to be very careful with our FOIL procedure. The left side is going to be 5a minus 9. The right side will be square root of 5a minus 3 times itself. And again, we're going to be very careful. The left side, 5a minus 9. The first term of FOIL will be root 5a times root 5a, which is root 25a squared, which is 5a. The middle terms of FOIL will be minus 3 times radical and minus 3 times radical, making minus 6 root 5a. And the L term of FOIL, negative 3 times negative 3, will be positive 9. I notice that I can subtract a 5a off of each side and it's gone, and I can also subtract 9 off of each side, and that will give us negative 18 is equal to negative 6 root 5a. Now, we still have a radical in our problem, and we need to isolate it yet again. So we will divide each side by negative 6 and find out that we have 3 is equal to the square root of 5a. Okay, that's good. We have our square root equal to a positive value. Squaring both sides again is going to give us 9 equals 5a, and a then, after divided by 5, will equal 9/5. Now, that will check if you do substitute it back into the original problem. This next problem looks to be very much like the previous one that we just did. We're going to have to square root both sides. We've already got the p plus 7 radical isolated on the left, so squaring the left gives us p plus 7, and on the right we're going to have the square root of 2p plus 1 times again the square root of 2p plus 1. On the left, no change, but on the right we're going to do the FOIL procedure, and that will give us 2p plus 1 radical and 1 radical makes 2 radicals of 2p plus 1. Now we look at what we've got, and we want to again isolate the radical that we have here. So that means the two other terms with it on the right are going to have to be subtracted off. So subtract 2p on each side of the equation and subtract 1 on each side of the equation. Leaves us with negative p minus 6, plus 6 is equal to 2 square roots of 2p. At this point, I really don't want to divide each side by 2 because that will create a fraction. So I'm going to just square things as they are and be very careful. I'm going to have negative p plus 6 times itself on the left, and on the right, the 2 in front will square to a 4, and squaring the radical will give us a 2p. Notice I've used parentheses here, and that is what we're going to have to do. There's no more radicals involved, so now it's time to actually do the multiplication on the left. We're going to have p squared minus 6p and minus 6p making minus 12p plus 36 is equal to 8p. Since this is a quadratic equation, we're going to need to set it equal to 0 and subtract that 8p off of each side, and that will give us p squared minus 20p plus 36 is equal to 0. This will then factor into p minus 18 times p minus 2, and we have two potential solutions of 18 and 2. So let's go and check each of those values. Let's begin with the 18. 18 plus 7 is 25, which square roots to 5. So just remember the left side is 5. On the right side, 2 times 18 is 36, which square roots to 6, plus 1 is 7. 5 equals 7 does not check. So we need to cross off 18 as a potential solution. And now we need to check the 2. Substitute 2 into the problem. 2 plus 7 is 9, so we have the square root of 9, which is 3. On the right, 2 times 2 is 4, square roots to 2, plus 1 is 3, and so that one does check, and 2 is our only solution to this problem.